Perfect. So with this video, we start a new section to the course, and this section is all about looking into some sort of real use case of vector embeddings other than RAG, other than retrieval augmented generation. So if you're someone who is pretty much interested in making sure or exploring things on how you can make use of vector embeddings in your real life applications, if you want to step out of the box and go one step further with having a look at real life scenarios, well, you have stumbled upon the right section. So in this section of the course, we will be covering a project that I built. So I'll be giving you some sort of an idea. I have created a Jupyter notebook which has the logic behind this project, the overall high level abstraction logic behind this project in the form of a Python code. We'll be running that, we'll be understanding how the project was built. And yep, that's what this section is going to be about. So the project right now is live and it's hosted on an Azure website. It's an Azure App Service Plan. I created a Dockerized image of this website, hosted that on Docker Hub as a public registry, and then there you go. I hosted in on Azure App Service. So if you want to check this project out on your device, you can navigate over to this URL, Azure Icons Search Engine.azurewebsites.net. Don't worry, I'll be attaching a link to this in the resources section of the video, so you can grab that from there. To give you a brief introduction of what the project is about, the project is uh, at the very heart of it. It uses vector embeddings, and what led to the development of this project is I, being a Udemy instructor, it's very important for me to create engaging presentations. And for creating engaging presentations, as far as the visual side is concerned, I have to do a lot of digging, a lot of search uh, into, searching for SVG icons of various Azure resources. These could be the icons of, let's say, storage account, the icons of, let's say, databases, and a bunch of them. And a problem that I stumbled was I, in the very first search, could not find the right SVG icon. So for this, what Microsoft gives you, it gives you a zip folder which contains all of the SVG icons in a zip folder. But the thing with that zip folder is, even if you extract that zip folder, you have to go to the File Explorer and search for the exact name of the file to get that SVG icon. But that really doesn't solve the problem for you, right? You have to make sure that you match the right file name, and it's astronomically impossible. It's next to impossible. I mean, what are names can you just remember? So for that, I built some sort of a search engine which uses vector embeddings in the backend to semantically map the user query with the uh, set of images for which I have developed a data set and stored that data set in Azure Cosmos DB. So let's if we were to go to this website and search for, let's say I'm making a presentation on Azure AI Search, and if I type in Azure AI Search and hit the search button, it's trying to retrieve content from my database. So essentially, it's Azure Cosmos DB running in the backend with vector embedding stored in it. And in a couple of seconds, we're going to get images for Azure AI Search. There you go. So you get top 5 images for Azure AI Search. Uh, so if you notice, I have a section for similarity score, which is essentially uh, converting the user query into vector embeddings and then comparing the vector embeddings that were generated for the image with the user query, and then mapping down a similarity score that's a value ranging from 0 to 1. So in the data set, I prepared the image name, image description uh, as text fields, and on top of these image name and image description text fields, I generated vector embeddings. And if you were to download this image, you can go to this download link. So it takes you to a download link, and then you can, click on save as. Maybe just quickly save it over here, and then use it in your presentations. So this is how the website works, and it includes a couple of SVG icons. So let's say if I go to search for Azure Sentinel, which is a security product from Microsoft, I'm going to get back an SVG icon for that as well. So if you notice, I get back the Azure Sentinel SVG icon. So it's like a search engine built on top of these images. trying to solve a real life problem. And for this reason, because it's going to come in very handy for me. Also, it's going to come in very handy for you if you're preparing presentations. You can just quickly navigate over to this website and have a look at it. And again, if you were to read how this project was made, there's a documentation that I prepared. So if you click on it, it takes you to some sort of my best attempt at writing a research paper, so that I navigate in this paper. I navigate you through the steps that I took in mind, maybe some discussions, analyze the outputs, and then discuss a bit about what could I have done, what are the uh, potential explorations that I could do, and yep, that's all about the documentation. So you can navigate over to this documentation as well. It's gonna beautifully supplement the Jupyter notebook that we will run as part of having an abstract level view of how the project was developed. And again, I did some sort of branding for myself as well. So if anybody were to stumble upon this website, uh, they would get to know that I am a Udemy instructor and these are the links to my courses. So yeah, props to me for that, I believe. So again, that's pretty much it about the video. Was an introduction to this section of the course that we'll be starting. And yep, I'm pretty excited. And with this, let's quickly move on to the next set of videos. So before we can start on with testing this project out, we need to first of all deploy some resources back into Azure. And before even deploying these resources back into Azure, let us go through the overall architecture. So first things first, for data preparation purposes, we need these SVG icons. So we're going to be storing these SVG icons in an Azure storage account inside of an Azure storage accounts container, a blob container, wherein each of these SVG icons will be called as a blob. So point number one, we need to configure an Azure storage account. Secondly, uh, because I will be utilizing GPT engines and text embedding engines of Azure OpenAI resource. So first of all, uh, we will be utilizing the GPT-4o engine uh, vision capability to pass in these images that are stored as blob in Azure Storage Account blob container, so that this GPT-4o engine can generate fields for each SVG icon, such as name, description, similar words. Uh, and then we will be passing this data set with each SVG icon URL and these sets of text fields to text embedding ADA002 model, which will generate vector embeddings on top of these text fields. We need to deploy an Azure OpenAI resource. So point number two, we need to deploy an Azure OpenAI resource. Then we will be storing this dataset into Azure Cosmos DB for NoSQL API with vector support. So point number three, we need to deploy an Azure Cosmos DB resource with support with vector support, and that's going to be NoSQL API. So that's one thing that we need to keep in mind. And yep, that's all about the resources that we would want to deploy into the Azure portal. But to just give you how the project works, first of all, because we have the text fields, and on top of these text fields for each SVG icon, we have generated text uh, embeddings using the embedding engine. We store all of this data set into Azure Cosmos DB. Now, what happens is whenever, let's say, in the search bar of the website, I type in Azure AI Search, the user query of Azure AI Search is again converted into text embedding into vector embeddings. If you see the arrow going over here, the orange arrow, and the vector embeddings of this user query are compared with the vector embeddings that are stored in Azure Cosmos DB. And by algorithms that are working in the backend, such as diskANN and all the cosine similarity functions that Azure Cosmos DB lets you uh, configure, you find the best set of SVG icons that can be used to answer the user query, that can be used to be presented to the user. So I run a SQL query in the backend. This SQL query in Azure Cosmos DB has inbuilt support for vector searching as well as computing similarity scores. We're going to have a look at that SQL query. I run a SQL query. That SQL query gives me top five SVG icons that can be used or can be used to be presented to the user, and then in the front end of the website, I present these list of five images from this Azure Storage Account blob container to the user. So this is how it works on a high level abstraction. on an overall architecture basis. Right now I'm on portal.azure.com, and let's first of all create one new resource group in which we're going to store all of our resources. So let's say the resource group name is going to be Udemy demo. Uh, region East US looks perfectly fine, and I'll just quickly create that. And as far as the architecture goes, if you look at the architecture over here, we need to create an Azure Storage account, and yeah. So let's first of all create that storage. So storage account, click on create, and let's give this storage account a name as Udemy demo str account. East US geo redundant storage. Yep, let's hit the review plus create button and hit the create button. So our storage account is also getting created. In the meantime, let's deploy an Azure OpenAI resource. All right, so let's quickly move forward and deploy an Azure OpenAI resource. And if I'm not mistaken, I think the GPT-4o engine is available in only some set specific regions, with Sweden Central being one of them. So I'm going to deploy an Azure OpenAI resource in Sweden Central. If that's not available for you, then you please move forward by searching on the net, as in which region you should deploy the Azure OpenAI resource, so that you get an access to the GPT-4o engine. So Sweden Central is going to be my case, and Udemy demo OpenAI. Pricing tier is standard as 0, and let's click on the next button. Next, and I'll create. Yep. And now we also need to deploy an Azure Cosmos DB for NoSQL API resource. So let's quickly go there. Azure Cosmos DB, click on create. Select the first option, the Azure Cosmos DB for NoSQL. So there are two uh, supports, two types of Azure Cosmos DB accounts that have a support for vector embeddings, with one being NoSQL API and the second one being MongoDB vCore API. Resource group is going to be Udemy demo. Yep. An account name, let's give it Udemy demo Kuljot ACC. And because we are in the developer mode, we aren't publishing a full-fledged application. Let's keep the capacity mode to being serverless and not to provision throughput. So let's keep it being serverless. Location based US3 absolutely looks fine. And let's hit the review plus create button and hit the create button. So it's going to take maybe 3 to 4 minutes for the Azure Cosmos DB account to get created. So yep, it takes some time. But in the meantime, we can upload the images to the storage account for the purpose of data preparation, right? So I'll quickly navigate over to my storage account. That was Udemy demo str account. Yep. And let's upload the images over here. So I'll go to, first of all, we need to enable anonymous blob access on this storage account. So that for that we will go to, I think it's gonna be under maybe, yep, settings. You go to first of all the settings and then to the configuration area. So for accessing storage account, if blob anonymous access is not enabled, you need to have a, a key connection string that contains the token, a key or a token that lets you, that contains the permissions that are associated with that token. Yep, that's called as SAS signature, or a secured access signature, something of that sort. So if that's not there, if you only use the blob URL, it's not going to work. You need to have a key or a token associated with it. But we are not going to run into the hassle of creating a key or a token every time. A shared access signature every time. Yep, that's the word, the shared access signature. So what we'll do, we'll enable blob anonymous access. So just make sure that you set it from disable to enable and click the save button. Just double check it. Yep. So blob anonymous access is set to enable. There's a bug. It doesn't change quite a bit sometimes. So make sure you double check it. And now let's go on to the containers area, which is under the data storage tab. And let's create a container in which we're going to store all of our blobs, which are essentially the images. So anonymous access level, I'll set this from private to maybe container level. Yep, container level. And then create. Oh, sorry, I forgot to put the name. So let's put the name as Azure Icons, if that's okay. Yep, Azure Icons. And then let's navigate into it and upload our images. So I have a folder that contains SVG icons of AI and machine learning resources for Azure resources. So I'll be attaching this folder as a zip folder in the resources section of this video. So make sure you grab that from there and maybe test things out on your end if you're doing so. So I'll quickly upload these icons and click on upload. Yeah. All right. So we have our icons uploaded. Now let's go on and check whether the Cosmos TV account was indeed created for us or not. Yep, Udemy demo Kuljot account it is. Looks like it's been created. So first things first, because right now the day that I'm shooting the video, the vector support in Azure Cosmos DB account is not enabled by default. So you need to go somewhere into it and then enable it. Uh, because right now it's in preview version, it's not in the general available version. And whenever you click on the enable button, it takes in around 15 minutes to settle things in. So we're gonna have to wait some time, or maybe we can move on with the demo. And by the time that we reach the Python or Jupyter notebook, uh, hopefully things would have settled into place. So let's go to the settings area, the settings, and under the settings area, let's go to features. And in features, there's something which is called as vector search for NoSQL API. So right now it's set to off. You need to set it to on. So I'll click on it and then they'll click on the enable button. So it's going to take in around 15 minutes for things to set in. So yeah, really nothing we can do about it right now. So let's go to our uh, Azure OpenAI resource and deploy the GPT models in the text embedding models. So Udemy demo OpenAI, and then from here, I'll go to the Azure OpenAI Studio. So Azure OpenAI Studio is available in the overview section just over here. Sorry if I sped things up a bit. And from over here, let's quickly go to the deployments section, which is under the shared resources area. And let's click on deploy model. It's going to be a base model. And if you have a look at the architecture, we need to deploy GPT-4o engine, which has vision capability support built into it, and then a text embedding model for generating vector embeddings as well. So there should be GPT-4o. Yep, there we go. Uh, GPT-4o. This is the one that we're looking for. GPT-4o chat completion. All right. And if I'm not mistaken, they have also released the GPT-4o real-time preview, which has audio generation inbuilt into it as well. So if you're looking for building a chatbot that has audio capabilities built into it, if you do not want to run into the hassle of, let's say, creating an Azure speech resource and then throwing multiple API calls to, first of all, let's say the Azure speech resource to convert speech to text, then throwing a call to GPT engine, getting back a text response, and then again throwing back a response to speech resource to convert text to speech, and then finally displaying the user. That is a lot of hassle. Uh, this engine solves the problem for you, and it's real time. It has very low latency. That's the beauty about GPT-4o audio generation engine. But yeah, let's quickly move on with the video, or else it's going to be a pretty long video. So I'll just click on confirm. Uh, and from over here, let's set in the configurations. So deployment type is going to be global standard in which you will have to pay per API call. So we're going to be billed pay as we use, and capacity, I think 10K tokens per minute is going to be absolutely fine. But that's pretty much it about the GPT-4 resource. Let's hit the deploy button. Yep. So we have deployed a GPT-4o. Now let's deploy a text embedding model. So I'm going to click on deploy base model. And from over here, let's click on, or let's rather select text embedding ADA 002 engine. So text embedding ADA 002, it generates 1536 dimensions, whereas the text embedding 3 large generates 3072 dimensions. I think it's double that, yeah. 1536 into 2 is equal to 3072. But the only thing is, right now, the day that I'm shooting the video, although using text embedding 3 large model will uh, will rather capture the semantic and contextual meaning of the text fields, helping me to build a better search engine. The only thing is, in Azure Cosmos DB for NoSQL API vector support, you are only allowed to store not more than 1536 vector embeddings. So that's the problem that I uh, have found with Azure Cosmos DB, and hopefully in the future they're going to raise the bar to, let's say, double that of 1536 to 3072 dimensions. Hopefully, they're going to do that in the future. But right now, let's deploy text embedding ADA 002 engine. Deployment type again standard, and capacity 120K tokens per minute. Absolutely looks fine. And let's click on deploy. Yep, so that's essentially the part about setting things up. So let's quickly go over to the architecture and double check things a bit. So we have deployed an Azure Storage account, uploaded images to this as well. Deployed an Azure OpenAI resource, and inside of that, we deployed a GPT-4o engine and a text embedding ADA 002 engine as well, and deployed an Azure Cosmos DB for NoSQL API account, and have enabled vector support, but for which we'll have to wait for 15 minutes. It's going to take some time for things to settle in. So I think that's it about the video. That was all about setting resources into portal.azure.com so that we can move forward to testing the Jupyter Notebook out, in which we get some sort of idea, the overall idea behind the project, the overall logic behind the project. So yep, with this, let's quickly move on to the next set of videos. So now that we are done with launching one of the resources back into portal.azure.com, now is the time to test our project out. Test the Python notebook out, the Jupyter notebook out to get uh, some idea about what went into building this project, what's the underlying logic. So the GitHub repository that we'll be using for this demo is going to be with the name being Azure Icons Search Engine. It's in my public GitHub profile. So this is the URL for that. Again, don't worry, I'll be attaching a link to this GitHub repo in the resources section of this video. So make sure you grab that from there. So once we have this GitHub repository, I'm just going to quickly go into my Visual Studio Code and then clone this repository. So Control Shift P to open the command palette, uh, git clone, paste the URL, and then I clone from the URL. And let's save it in downloads, maybe make a folder as in Udemy demo repo, and I'm gonna store this in this particular folder. And then if you notice, this is the same GitHub repository that I use to create a Docker image and then publish that to an Azure website. So if you notice in this SRC folder, all the backend and frontend has been written. So the backend is in Python. There's the Docker file for the backend, and the frontend is written in React.js using Vite as a development server. But not really going to go into how this project was built. Let's cut to the chase and go to the notebooks part of it. So this is the folder that we're going to be working with, notebooks. So it contains a Jupyter notebook file and an environment variable file wherein we can set the environment variables such as the keys and the endpoints to which we need through API calls. So let's go to .env.example and let's quickly rename this. So I'm just going to rename this to .env itself. Remove the .example part from it. So we need to set in the environment variables over here. We require an Azure OpenAI endpoint key, the GPT model name, the embedding engine name, the storage container name, Azure storage connection string, Cosmos DB connection string, the database name that we want to create inside of Azure Cosmos DB, and the Cosmos DB container name, which we want to create inside of the database that we have created inside of Azure Cosmos DB. So it's going to be a long, uh, bit boring to set in all the environment variables, but much needed for us to move forward. So I am in the Azure Cosmos DB resource, and I think the vector search is enabled. So if that's the case, the status should read as on. Takes in around 15 minutes to settle things in. Now let's quickly grab I think we require a connection string. All right. So I'm going to go to the settings area and grab the keys from there. So inside of the keys area, you're going to have the connection string. Yep, that's what we require, primary connection string. So let's click on this I symbol to decrypt it and maybe let us copy it. So yep, copy and Cosmos DB connection string. Yep, there you go. And because it contains special characters, some escape characters, escape sequences as well, you need to fit this in double quotes. So just going to do that, fit this in double quotes so that it's interpreted as a combined string essentially. Database name, give it any database name. I'm going to give it as Kuljot DB. Cosmos DB container name, give it any container name. So let's keep it as Kuljot container Cosmos DB. Or for the sake of simplicity, let's keep it Kuljot container itself. Now let's jump to the storage account part. So we need an Azure storage connection string, a container name, the container name of the storage account in which we have stored all of the SVG icons. So I'll go to my storage account. Yep, there you go. And from over here, let's go to containers inside of data storage. And I think we have created a container in which we have put all the Azure icons. So the container name is Azure icons. So storage container, Azure icons, and the connection string. All right. So let's go to the access keys area that's right under the security plus networking tab. And from here, we're going to get the connection string for the storage account. Uh, yep, this one. So click on show and then we can copy this. Copy the clipboard and then paste it over here. Again, it includes some special characters, escape sequences. So we're gonna need to insert double quotes, enclose this in double quotes so that it's interpreted as a combined string. Then we need to navigate over to the Azure OpenAI resource and grab the keys and endpoint, the GPT model name, and the text embedding engine name as well. So let's go to Azure OpenAI. Udemy demo OpenAI is the name. Uh, Go to resource management. Yep, resource management, and then keys and endpoint. So I'm going to copy the primary key first and paste it over here, Azure OpenAI key, and then you copy the endpoint. Yep. And we need to fetch the GPT model name. So you can go to the Azure OpenAI Studio from the overview section and go to deployments because we already deployed two engines. The name of the GPT engine is GPT-4o. So quickly copy this and paste it over here. And we require the embedding engine name. So it's text embedding ADA 002, the same as the model name. Paste that over here. And Control plus S to save the made changes. Now let's go through the Jupyter notebook. So this is how it looks like. And first of all, we'll be installing some important libraries and packages. So select your Python kernel to work with, the Python environment. I'm going to go with the global Python environment. So it's going to install the OpenAI SDK support, the storage account for Azure SDK support, and the Azure identity support, and a bunch of other libraries such as SVG Writer and I suppose words. Something to do with converting SVG icons to PNG icons. Perfect. Uh, Now let's initialize this variable as JSON output, which is a Pythonic list. I'm going to initialize that, and then from over here, we're going to import some important libraries and utilities that we just installed in this Python environment, the global Python environment. Yep, perfect. This is a Python function that is used to convert an SVG icon to PNG format. So what happens is whenever you use the GPT-4o engine vision capability of it, you can only feed PNG or JPG images to it. The support for SVG icons is not there. So because my icons are SVG formatted essentially, I require a Python function that converts these SVG formatted icons to PNG format, and that's a function that I've defined for converting SVG to PNG format. And it's done with using the Aspos words library. So if you notice, I installed the SDK support that was called as Aspos words. So it has some built-in functions and libraries that you can use to convert SVG icon to the PNG format. So that's what I've done here. Now let's look at a function, a Python function that lets me generate a local URL for the image. So whenever you feed an image to the GPT-4o vision capability API call, you can either fit in the entire uh, blob image URL or generate a local URL for the image. Now the thing here is, if I feed this image as a URL that points to my storage account, because in my storage account these are SVG icons and I cannot feed these SVG icons to the GPT-4o vision capability, I need to find a workaround. And that workaround is, first of all, converting that icon from SVG to PNG, storing it somewhere over in this folder itself, and for this folder, generate a local URL. That means a URL that is local, in fact. That's not a URL that points to my blob container or the image that is stored as a blob onto cloud. So for the same reason, I'm generating a local URL for this particular image. And for that, I am using, base encoding the URL and a bunch of code that's written over here. That's really not uh, required. That's just making sure that things fit right into place. And then we need to send these images as local URLs to the Azure OpenAI client, right? So first of all, we need to create an Azure OpenAI client that lets us connect to the Azure OpenAI resource that's deployed back into our portal.azure.com account. So first of all, with this, I'm importing the OpenAI key, the endpoint, the embedding engine name, the GPT model name from the environment variable file, and then moving forward, I essentially create this Azure OpenAI client that lets me connect to my Azure OpenAI resource and hopefully use the embedding engine and the GPT-4o engine essentially. And now this is where the main function is written. So this is the main heart of the heart of the first phase of uh, the logic behind the search engine, that is data preparation. So a thing here to be noticed here is, because I have a lot of SVG icons, uh, essentially manually generating text fields such as name, description, and similar words for each SVG icon manually it's just a time taking and a laborious task in itself. You would have to spend a whole day, maybe not a whole day, even 3 to 4 days in making sure that everything's correct. Now, this is where you use your brain and bring a GPT engine, the power of generative AI, into play. And that's what we're exactly doing with GPT-4o. So we're telling GPT-4o, well, hey, listen, I'm passing you some images in the form of local URLs. And please have a look at this image. And these images are essentially going to be of Azure icons. These are Azure icons of Azure resources, essentially. And using your knowledge that you've been trained on, using your existing knowledge base, make sure that you label these images correctly and generate text fields accordingly. So if you notice in the API call, this API call includes system prompt and a user prompt. And with the help of system prompt, I in fact instruct the GPT engine what it should essentially do. So this is where your prompt engineering skills come into play. The better you at defining what you want a GPT engine to achieve, what you want uh, the engine to behave as, the better it's going to work for you. So I say you're a helpful AI assistant meant to assist me in my work. I'm trying to build a solution that lets people search for Azure icons in their SVG format. I will be passing you an image for which you need to generate information in the following manner. Now, this is where concept of few shot prompting to generate better responses from a GPT engine comes into play. So I say these are the list of text fields. Sorry, the text fields essentially that you need to generate for each SVG icon. That I will be passing you as a PNG formatted icon. And these text fields are, first of all, it's going to be a name, a suitable name for the image, the description about what the resource is all about, and similar words. So, similar words essentially are the synonyms for this resource. So, these are the text fields that I've chosen. And with the help of few shot prompting, I display or I tell the GPT agent, well, this is how the sample output should look like. So this is how it should be structured in a way that it includes name, description, similar words, and the URL that points to the image. Perfect. So, and I also tell it the output format should not look like this. I ran into a problem that the GPT engine was outputting in a format that looked like this. So I specifically told my GPT engine the output format shouldn't look like this. And I also tell it, well, strictly adhere to this sample output format. And that's all about it. So and then I send a response, sorry, make an API call to the GPT engine in which I include the system prompt and the uh, local image URL and the user prompt. So this is the user prompt area in which you have two types of prompts. One is your text prompt. The second one is going to be your image URL because you're using the vision capability of the GPT-4o engine. So I tell it analyze and generate information for this picture according to the system prompt that is fed to you. Note that the URL of the image is in blob storage container, and then I also pass it the blob image URL. Now this blob image URL is essentially done to generate this kind of format that you see. That's not the URL that the GPT-4o engine will be using to fetch the image. The URL that the GPT-4o engine will be using to fetch the image is over here, the local image URL, right? The URL that I generate for the image after I convert the image from SVG to PNG. So that's it. And then let's run this function so that it gets stored in the memory of the kernel of the Python environment, and boom, there you go. And now this is the compiled function that I'm going to be generating or writing for data preparation. So all of the uh, small functions that I set into place, I compile them for the purpose of data generation. First function is going to be converting image to PNG. That takes the blob container URL, the blob URL essentially. Then I generate a local URL, and as part of the chat completions API, in which I tell the GPT engine, well, hey, I'm going to be passing an image to you. I invoke this function. And I also need to, first of all, pull images from storage account and then go on to trigger this function to create the data set. So with the help of this code, I will be utilizing the SDK support for Azure storage account in which I make use of it to create a client connect to my Azure storage account with the help of the storage Azure storage connection string as can be seen over here. And then I iterate over through each of the blobs that are stored in my storage account, and then similarly send an API call uh, to the GPT engine with the help of the compile function that I created right over in the previous cell to this one. So let's quickly run this, and it's going to take some time because again we're going to be generating some images. So I get an error over here. Name generate complete data is not defined. All right, so I forgot to run this code. So let's do this, and maybe hopefully it should get things into place. Convert image to PNG is also not defined. Oops, I forgot to. Yep, I forgot to run these uh, functions essentially. So let's run all of this function. Yep, I forgot everything. Looks like. So I'm gonna run everything from the starting, and yep, we'll hope things work out in the end. So there we go. Run this cell, run this as well. Function to convert SVG image to PNG format. Going to be running this. Generate local URL for the image. Create an Azure OpenAI client. There you go. Define the chat completion API. Generate the compiled function, and then pull images and trigger that function essentially. Yep. So it's working now, and it's going to take a couple of seconds, maybe 2 3 minutes, to get all of our images prepared. So if you see, uh, these are the responses that I get back from the GPT engine. That's what I'm expecting. Name, description, similar words, and then there you go, URL. So if you notice, it took it around 8 minutes and 16.7 seconds for all of that to get in text. So, yep, quite a lot of time because I think there were a lot of images. Not a problem. Let's get moving forward with the video. And all of this is stored, all of this data set, or rather the responses that I get, I stored it in the form of a JSON, in the form of a Python list, which was with the variable name of JSON underscore output. Now, what to do with this list is we iterate over through each object that is stored in the list, and then put it inside of this file that's with the name of data.json. So essentially, we have a JSON data set that we can use the text fields from, generate vector embeddings, append those vector embeddings to this JSON dataset, and then upsert this dataset into Azure Cosmos DB for NoSQL API database. That's what we're gonna do. For this, I'm trying to iterate upon through each object in this dataset and then store it in this file data.json. Write it essentially. So let's run this. Cell, and if you go over to the data.json, this is how the data set looks like. So right now we have the name, the description, the similar words, and the URL. The only thing left is to create a field for vector with the name of vector, and then store the vector embeddings as an array into it. So that's the second part. So let's go to the notebook again. And for this, I am defining a vector embedding generator function. So because we deployed a text embedding ADA 002 engine, uh, this is the vector embedding generator function. And the thing to be noted over here is I deployed my embedding engine with the name of text embedding ADA 002, the same way as the model name. But if you have deployed the engine with a name that's different from the model name, just make sure that you define it over here, or else it's going to throw in error. An API call to the text embedding in a 002 engine and generating vector embeddings for it. And what it's going to do is I will iterate through each of the object in this data set that's present, and then for the name field, for the description field, and for the similar words field, I'm going to generate vector embeddings. So I'm going to append the name, description, the similar words field into one single string, and then pass that string as an input parameter to the function, the vector embedding generator function. So that's what I'm going to do. So let's run this to load the function. And then if you notice over here, I am first of all opening the data.json file in a reading mode, and through each of the item, the object that's present in this file, I am fetching the name field, the description field, and the similar words field, and storing that in the form of string of characters. That's defined with a variable name as being data underscore for underscore embeddings underscore engine. And then I pass this data as an input parameter to the vector embedding generator function. And once I get back the vector embedding, I append this vector embedding as a field for each object. I define a new field for each object that's with the name of vector, and then I attach the vector embeddings to it. And then finally, once I have generated vector embeddings for all each of the object in the dataset, I finally open the data.json file in a write mode that's been denoted with over here, and then I finally write the data along with the vector embeddings. Uh, so let's run this, and in a couple of seconds, it's gonna uh, be over. Hopefully, it's not gonna take as long as 8 minutes. Yep, it got resolved in 8.6 seconds. So yeah, quite fast. Again, vector embedding engines are quite fast in nature. So if you go to the data.json file, now you have vector embeddings generated for the name field, the description field, and the uh, similar words field along with the URL. So now we have the data set prepared. That's solely done with the help of GPT-4 row vision capability. Really cool use of the brain over here. Now we upsert this to our Azure Cosmos DB container that's been created inside of a database. Let's go to the notebook again, and now let's deal with Azure Cosmos DB. So first of all, I'll download the SDK support, the Python SDK support for Azure Cosmos DB, and then let's create a database client first. So with the help of this SDK support, I will create a database client that lets me connect to my Cosmos DB resource with the help of the connection string. With the help of the database name, I'm going to create a database if it doesn't exist. Right. So let's run this cell. Yep. And let's define a vector embedding policy. So before we can create a container inside of a database for defining a we need to define a vector embedding policy. So in this vector embedding policy, I tell, well, I'm going to be passing vector embeddings. These vector embeddings are stored in this path. The distance function, the function that's going to be used to compute the similarity scores between the user query and the vector embeddings in this data set is cosine similarity. And the dimensions of vector embedding that I'm going to be passing to you is 1536 because I've used the text embedding ADA002 engine. Uh, yep. And then let's define a vector indexing policy. So once you've defined a vector embedding policy that lets you compute similarity scores, the next thing to define is vector indexing. How you're going to arrange vectors inside of your database. So there's a Microsoft proprietary algorithm that's called as DiskKNN and lets you arrange vector embeddings in a quantized manner, in a compact manner. So again, Microsoft has a research paper on this algorithm. So if you want to check this out, maybe you can go to the uh, Microsoft research blog post and check things out from there. So let's run this cell and let's create a container finally. So if you notice, when I'm creating a container, I'm passing the indexing policy and the vector embedding policy as well. So once I created the container, if I go back to my Azure Cosmos DB account, yep, you get the database that's been created with the name of Kuljot DB and the container with the name of Kuljot container. And then if you notice, all the items will be available over here. But right now we haven't upserted our items from this data.json file. So next things about upserting items. Yep. So with this, we upsert our data into the container from this data.json file. So for that, I open this in reading mode, load that, and insert each of the item with a unique GUID. Uh, yep. And name JSON is not defined. Maybe I did not run a cell that was stored above. So let me just code this a bit. Import JSON, and then I'm going to run it. It's going to take a couple of seconds, if not minutes, to get over here. So now if I go back and maybe refresh my browser, let's see if things got into place or not. Yep, so if you open the container and go to the items, yeah, so I get each item with a unique GUID, and there you go. You get the name, the description, similar words, URL, and the vector embeddings for each of the item. Beautiful, beautiful. That's the optimization of my database. Now let's see how we sort of try to map the user query by generating vector embeddings for the user query with the vector embeddings that are stored inside of a Cosmos DB account and then present the user with the top five images. So let's say if I enter a user query, as in, let's say I want to search for the this user query of Azure Cosmos DB isn't going to work. Let's say if I want to search for Azure AI search because we have uploaded images of Azure AI search. So first of all, I'm going to vectorize this user query and print the vector embeddings for this particular user query. So for this particular user query, these are the vector embeddings that I get. Perfect. Now comes the part where the SQL query comes into place. So this is how the SQL query looks like. So I tell with the help of SQL query that select the top five items, the name field, the description field, the similar words field, and the URL field of the top five items are denoted by C. Each item is denoted by C over here. So extract c.name, c.description, c.similar words, and c.url. Based upon the condition that you compute the vector distance between the vector embedding field of this particular item and the user query embeddings on the algorithm of cosine similarity. Remember, we defined a cosine similarity algorithm in the vector embedding policy, so that's why it was pretty important. And what this cosine similarity does is it computes a similarity score. That's a value ranging from 0 to 1. Uh, and based upon this similarity score, I would arrange this uh, in sort of a descending order from the first image being having the highest similarity score between the user query and the text fields for it, corresponding text fields for it. And yeah, that's how the query looks like. I send this query to my Cosmos DB container. And finally, when I try to run the cell, I should get top five image recommendations. So these are the image recommendations that you get. Azure Cognitive Search, that's the description. So if I'm not mistaken, that's one, two, three, four, and five. Yep. So if you scroll down, or if you scroll sideways, uh, if you notice, this is the similarity score for each item. And these items are arranged in descending order, with the first one having the greatest similarity score and the last one having the least similarity score out of all of them. And I get the image URL as well. So if I were to navigate over to this image, this is the image, right? That's the SVG icon I was looking for. So you can right click on it and then save as, click on the save as and save it on your device, on your local device. So that is how the Azure icon search engine works in real time. That's the main logic behind it in a very compact manner that I've tried to explain you with the help of a Jupyter Python notebook essentially. So yep, that's pretty much it about the video. Hopefully you can play with this Jupyter notebook a bit by rather searching for other Azure related things such as Azure ML Workspace or something of that sort, maybe Azure Cognitive Services. Play with it around a bit, and hopefully with this video I made you guys learn a lot about uh, or maybe I was successful in letting you guys peek into vector embeddings through a different perspective, through a perspective that was very different from the same old RAG view that you would always think of whenever vector embeddings came into play. So that's pretty much it about the video. With this, let's quickly move on to the next set of videos.